Hello everyone, I'm Mazhar Ali Beg. I'm a master's student in computer engineering at Tandon School of Engineering, and I'm very excited to delve into my research on enhancing operating systems efficiency with LSTM-based resource allocation. LSTM is long short-term memory networks, and this project was a part of the Introduction to Operating Systems course, and I look forward to addressing the most pressing challenges in distributing operating systems through the innovative machine learning approaches that I've learned in other courses that I've had during my master's degree. Uh, so let's move on to the problem. The core problem is basically that in distributed operating systems, managing resources efficiently under unpredictable and variable user demands is a significant challenge. The traditional allocation methods often fail to adapt quickly, leading to degraded system performance. And a very prime example of this challenge was witnessed in India during COVID 19, the pandemic, when they were using the Coven platform to distribute COVID 19 vaccines. So basically, the Coven platform was a website that the government of India came up with, where, as and when the certain age groups were allowed to book their vaccinations, what would happen was there would be a sudden influx of users trying to book these vaccine appointments, and hence it serves as a perfect case study for us. So when new demographic groups were made eligible, the system experienced immense strain due to the traffic spikes. This led to very often it led to like server timeouts or slow response times, and this scenario was I mean clearly illustrated that there is a need for more adaptive and responsive resource allocation systems in distributed operating systems. Um, and that brings us to the hypothesis that I have, and in my research, it's grounded in the hypothesis that the long short-term memory networks, which are very often proficient in processing time series data, can significantly improve resource allocation in distributed operating systems. We believe that long short-term memory can accurately forecast resource demands. Uh, this would enable the system to pre-allocate resources more efficiently and reduce overall net latency. We do have quite a bit of related research in this space. So some of the previous studies in resource allocations are here. You may find them in the paper of in the references section of my paper as well. Our study builds upon these prior research in proactive resource allocation. Uh, like the work by the scholars like Ravindran and Hagachi have pioneered algorithms and approaches in this field. Moreover, research by Lee et al. Using LSTM techniques in cloud computing. This provided valuable insights into how machine learning can enhance resource allocation in different contexts. So this was a really good resource as well. So let's quickly jump into the implementation. So the implementation phase of our research began with data collection primarily. So we used Apache JMeter to simulate realistic user interaction in a distributed operating system. This step, as you may know, was very crucial for generating a dataset that accurately reflected the diverse and unpredictable demands typical to such systems. And we had these random spikes in traffic data spread throughout the dataset. And following the data collection, our focus shifted to pre-processing and feature extraction. We analyzed usage patterns and extracted critical features such as timestamps and resource types. We utilized tools like NumPy for data manipulation. We normalized the data, ensured that our LSTM model, which was developed on TensorFlow, uh, uh, which you might be aware of, could process it very effectively. The development of the model itself involved a very careful design of its architecture using TensorFlow. The model was structured with multiple LSTM layers, each fine-tuned to handle different aspects of the time series data, thereby enhancing the model's ability to learn and make accurate predictions. I will not go into too much details about LSTM models because that is not the uh, focus of this paper. It's the implementation. So following this, the model training had to take place, which was a very meticulous process. I employed a split of 80-20 for training and validation data, with a focus on regularization techniques like dropout to prevent overfitting of the model. The training was conducted on Google Cloud Platform, mainly because of the robust infrastructure that it has. It allows us to leverage the computational power for efficient model training and validation. So it was my first choice for a cloud partner. And the final step in implementation was the technical validation of the model. So under various load scenarios, mimicking the real world conditions on the GCP, this phase it basically tested the model's adaptability and robustness, ensuring its effectiveness in accurately predicting resource demands in different usage situations that we had previously generated using the Apache JMeter. Now, moving on to the findings that we had from our study. The findings were pretty significant. The long short-term memory model not only showed improved throughput and reduced latency as compared to traditional methods, but also demonstrated a notable enhancement in resource utilization, proving the efficacy of our approach in managing resources in distributed operating systems. So these other methods, we had these other methods to compare with as well. For example, reactive resource allocation, where the system, when it detects a spike in user activity, it chooses to increase the allotted resources, and also other techniques such as static proactive methods, where we predict beforehand if there will be user activity, or Q-learning as well. And LSTM proved to be it increased throughput by way more than expected. And yeah, further analysis of the model performance revealed that its strengths in different operational conditions, the accuracy and loss metrics over various epochs during the training phase indicated successful learning and generalization capabilities. This validated our hypothesis of for the effectiveness of LSTM in resource allocations. As you can see, the validation accuracy was, as expected, a little lower than training accuracy, but pretty significant nonetheless. And the model loss over epochs, validation loss, as expected, was slightly more, but it was what I was expecting. Now, moving on to what the next steps are. Uh, Looking ahead, I aim to broaden my research by integrating other machine learning techniques with our long short term memory model. We plan to implement and test this model in live environments using across various platforms, assessing its scalability and practical application. This was more kind of a sandbox environment where we had synthetic data generated. The it would be what do you say more it it would running this on real practical data sets would give us much more insight into how the LSTM model is would be great for proactive resource allocation. And the future work is geared towards solidifying the role of LSTM networks in revolutionizing resource management and distributing systems. And yeah, with that, my 10 minutes are up, and I'm, I'm glad to have gotten this opportunity. Hope you enjoyed this paper. Please give it a read and let me know what you think. Thank you so much.